Okay, so the next challenge is our next instruction, move AL58H. So this instruction right here, so we'll just copy this line into the description. Let's jump to, I guess I would like to keep this documentation page in front of me as I'm moving along, so I'll just go ahead and duplicate the tab right here and go back to the index, and so from this index I can jump to the instruction, another version of the move instruction. So we have seen this page already, so I'm just going to scroll down to move, and the opcode is B0. Okay, so B0 is found here, B0 plus RB. And so let's copy and paste this line from the move reference page, and that should tell us what this instruction includes. So this is a move instruction, and I'll just keep the description, okay, description like this. So this is all a little cryptic, but fine. So the opcode tells us that this is instruction move, which is moving immediate 8-bit value 58 hexadecimal to 8-bit size register. Okay, and of course 8-bit size register is indicated by plus RB. So this RB, okay, RB is of course equal basically B0 minus B0. You see what happens here? That we have the value here, which is B0 plus RB is our instruction, which is B0. Therefore, BZ equals 0. Okay, so it's 0, 0. And the documentation should tell us how to interpret plus RB. And it's a register code from 0 to 7 added to the hexadecimal byte given at the left of the plus sign to form a single opcode byte. Okay, so that's our case. Okay, so this is explanation for RB, copy and paste. So basically, again, RB is a register code from 0 to 7. Of course, we have 0. And the easiest way of doing it is just to jump into the register field and take a look at 0. Of course, our 8-bit register is AL. So here we can say that 0, which indicates register AL, and that's exactly what we're using in our instruction, right? So we use register AL. So this kind of explains what is happening. Does this instruction include mode RM byte? No. If yes, explain, not applicable. Explain the presence of any additional bytes. So basically 58, right? 58 hexadecimal is the ASCII encoding of character X, right? So character X, so we know this from our code already, right? If we look at this, it's the encoding of character X, and stored as an immediate byte, right? Immediate byte value. And the documentation told us, the documentation right here told us that this is an immediate value move to register 8. So of course, so this is where we know this information, immediate byte, right? So we can even say that this is the Intel reference manual indication of of this. So this character is stored directly in this instruction, and the size of this instruction is 2 bytes. Now, of course, I don't know if I should remove these addresses, but just perhaps they can be removed from this answer because they just happen to be the addresses in memory where our instructions are residing. So this is, just ignore this, I guess. I mean, we could do it like this, but I think it's easier to kind of identify because if you want to like jump back and forth, you can, instructions there could be the same instructions in the program, but in different memory addresses. So this has some use to what we do here to keep track of everything that we do. I recommend that you periodically save your work, not to lose all of this crazy copying and pasting and typing. So save changes, right? So let's make an update and continue with the next challenge. Okay, so this is as far as we've gotten. So the next is yet another move instruction, which we have in our sample program.